Hello everyone, welcome back to the channel. Welcome back to the Study Prep channel. So for today's class, we'll be mainly looking into the sine and cosine rules. That will mainly be what we're looking into today, sine and cosine rules. So without further ado, let's begin this class by looking into the sine and cosine rules for today. So basically, the sine and the cosine rules are basically the rules that shows us how to calculate for the sides of any triangle. So this is basically particulate about triangles, only triangles. So it's mainly about triangles, right? So that is what the sine and cosine rule is about. So let's go live stream. We'll mainly just be doing research. You could comment, you could like, and you could look generally. So let me look up sine and the cosine rules. So let me bring up this tab, and the stream might be a bit long, but that'll be okay. So let's go into that now. So the sine and the cosine rules. Let me bring this up and show you guys. Everybody could see that. So hopefully everybody could see that. So basically, the sine and cosine rules are mathematical formulas used in trigonometry to find angles and angles. Here's a brief overview. Sine rule used to find an angle from three sides of an angle, or a side of from three angles on the side. So let us now go into like a this is look like a very interesting diagram. This is supposed to work very nicely. Alright, let me view the image. It take a couple seconds. Alright, it's there now. Hopefully stream don't crash. Should be okay. Alright, we got it here. So the sine rule. So as you could see here, the sine rule has for like for example a sine a equals to b over sine b, sine c over sine c. So we have inside class we call it little a, we call it little b, and little c. We have big A, which is opposite of from here. If you could see, wish I had something to like here. If you see here, this big A is the opposite side of this A, and this C is the opposite of this C here, and this B is the opposite of B, this thing here. So as you could see from there. So the cosine rule. So we have the sine rule equals for A square equals B square plus C square minus 2 BC, which is here, cos A, and this big A is just the degrees, right? So if the sine rule is not working, we usually just resort to the cosine rule. And the sine and the cosine rules are for calculating any angles other than the typical angles that we would consider to be like, for example, um, like right angle triangles in particular, we use Pythagoras theorem and what's not. Pythagoras theorem is what we use to calculate the what we typically use to calculate right angle triangles sides. But when it comes to degrees and what's not, when it comes to calculating what's not, that's when we resort to calculate and missing sides of angles using Pythagoras theorems. But when it comes to calculating degree the degrees of an angle, that's when you resort to the sine and the cosine rules. So for this class, so um, from this image, I need to put this on the screen. I put this here on the screen right now. So it says the sine rule, two sides and a not included angle. So the same thing, um, A over sine A, B over sine B, and small c over sine or sine c. There are two ways you can solve this. There's either could utilize the cosine rule of a squared equals b squared plus c squared minus 2bc. That is another way of solving that. So that is another way of solving it. So now let's go into the history of the sine and cosine rule. So for now, we're going into the history of sine, which will be very interesting in itself. So early studies of triangles can be traced to the second millennium BC in Egyptian mathematics, behind mathematical purse and Babylonian mathematics. Trigonometry was also prevalent in Kushite mathematics. Systematic study of trigonometric functions began in Hellenistic mathematics, reaching India as part of Hellenistic astronomy. In India, but I don't like using Wikipedia because I think it's sometimes unreliable. So let's see, you could use. Anyways, we'll use that. So let's go into the actual history. So it says here, when during the Middle Ages the study of trigonometry continued in Islamic mathematics by mathematicians such as Khwarizmi and Abu al-Wafa. It became an independent discipline in the Islamic world, where all six trigonometric functions were known. Translations of Arabic and Greek texts led to trigonometry being adopted as subject in the Latin West, beginning in the Renaissance with Regiomontanus. Development of modern trigonometry shifted during the Western Age of Enlightenment, beginning with 17th century mathematics, Isaac Newton and James Turner, and reaching its modern form with Leonard Euler. All right, let's look into the etymology. Etymology. So the term trigonometry was derived from Greek. I don't want to say that word. So it was derived from a Greek word. The modern words sine and cosine are derived from the Latin word sinus means mistranslation from Arabic. Sine and cosine is a multi, particularly proof influentially established in the term. The word tangent comes from the Latin word tegens, meaning touching. Sine, since the line touches a circle of unit radius, whereas sinent stems from Latin seasons, cutting, since the lines cut the circle. So I think that's about it. We'll take a important. But as we continue, this is basically the history of sine and cosine. So what we do understand is that the sine and cosine mainly derived from the Egyptians. I think that's right. Let me just check back. Um, it was it was mainly constructed in mathematics. So it could be traced to the second millennium BC. This is before Christ. Yeah, in Egyptian mathematics and the Babylonians. So the portions or the states that mainly brought about it was India and Babylon, which were the main pioneers of trigonometry and generally sine and cosine. So the the word cosine was originally the root word for sine is it really derives from the a Greek word, whilst cosine derived from Latin word. So let me see small, large. Let me see dark. Yeah, that's better. Let's do a little bit more read up. So let's look into this video here. I'll put it on right now. So let's both watch it. Let's look at it. Yeah, there's a the clip there. A little, basically a little history into sine and cosine. So that's basically what it is. So hopefully after this we have a basic understanding, including you and myself, because this is the first time I'm studying it. Not first time, the second time, but I'll make a video on it in particular, explaining the full history of it. When that video comes out, you can watch it with me, or you can watch it. You can watch it. You could subscribe to that. You can gives it a thumbs up. And for this class, we just mean looking into like studying up on it, doing research and what's not. So let's look into this one here now. So you can check all these links. You could check all them out when you're finished and do some reading up. Alright, origins of the names of trigonomic functions. So introduction. Originally, all trigonomic Values were defined by the lengths of the sides of the triangles. The chord and the secant as shown in the figure in the following unit circle diagram. It wasn't until the 16th century that George Coachim Rheticus, a Tontic astronomer, defined the trigonometric functions as the ratios of the sides of our right triangles as we use them today. The lesson. In the diagram below, using a standard rectangular coordinate system, you see a unit circle of radius 1 with it centered at the origin 0, 0. This is very complicated, but I don't believe that's very useful for now. It's a nice site, but it's not useful. How did that show up? So let me show you this right now. So from the net, it says the sine cosine functions can be traced to the Gia and Kotichaya functions used in the Indian astronomy during the Gupta period. That is very interesting. So how is sine and how is a cosine related to sine? The various sine is related to the sine by formula for which x equals to negative 1 dash cosine x equals negative 1 dash cosine x. Just the sine turned reversed. Though through 90 degrees, the cosine follows a similar course in development in a notation as the sine. So that's their main similarity. What is sine and cos? In computing, they are typically abbreviated to sine and cos. So let me see if I could bring this out. I'll tab this right here because I believe it's very interesting. This is a very interesting term when it comes to sine and cosine, also known as SOHCAHTOA. Yes, SOHCAHTOA. SOHCAHTOA. SOHCAHTOA, yeah. So SOHCAHTOA is basically like this. Sine equals opposite over hypotenuse, cos equals adjacent over hypotenuse, and TOA equals to basically tan equals opposite over adjacent. That's what the SOHCAHTOA formula is. And SOHCAHTOA is a mnemonic device to help you remember the three basic trig ratios used to solve the missing sides and angles in our right angle triangles. It's very simplistic. So I think I'll wrap up this stream. It's nice to be doing this stream. I just pray that we could get some more viewers very soon and reach that 1,000 subscribers goal. So it's nice to be through, and peace out. Enjoy your day and watch the next video release on a full course into sine and cosine and even a little history into it. That will be 2 separate videos. So stay in touch, stay in tune, and that's related to the study prep guy. See you later. I'm a bit tired too.